Good morning. Let me start with the first session on Destination 1. Welcome back to Cluster 4 Info Days. My name is Anna Santoro. I'm a project advisor at the European Health and Digital Executive Agency, and today I will be moderating the Destination 1 on climate neutral, circular and digitized production. Before we dive into the different topics that are part of the 2024 call, I would like to invite Nicholas Delianakis from DG Research and Innovation to give a general overview of the destination. Nicholas, the floor is yours.
Thank you, Anna, and good morning. Let me start with a few general words about Cluster 4, Digital Industry and Space. Very broadly speaking, the cluster is about developing enabling technologies in for industry, digital and space, and applying them in industry, while applications of many of these technologies can and are pursued in other clusters and other parts of Horizon Europe. Now, the vision of this cluster is in one phrase, but technologies that respect the boundaries of the planet and reflect human needs. And the 6 so-called destinations of the cluster, which are in fact often closely related to each other, reflect this vision. Now, to say a few more words about the content, about what you will find in the 6 destinations. First, we have various approaches to help industry become climate neutral and circular. Those are the technologies that you will find mainly in Destination 1 that we are about to present. And where we have 3 of the partnerships that Peter Dröll mentioned this morning. Then we have the industrial and digital transformation, including as I said, the technologies that we need to make industry more autonomous and secure value chains. And finally, there is Destination 6, which is about the human-centric aspects of the various industrial and digital technologies. Though that said, you will find those elements in the other destinations also. Next slide, please. And now we can start with the first destination, climate neutral, circular and digitized production. That includes 3 industrial partnerships that support the manufacturing industry, energy intensive industries, including clean steel, and also a topic outside the partnership on construction. This afternoon, we will look at the second destination. Now, I will say a few words about that apply to Destination 1, Twin Green and Digital Transition as a whole. And in fact, the business case and exploitation strategy also applies to Destination 2. So let me start with the partnerships, 3 of which, as I said, are in Destination 1. You will find that in the 3 partnerships, we have a pilot that looks at the use of 60% funding for innovation actions for with-profit entities. That is used in some of the innovation actions in place of the normal 70% funding for with-profit entities, while in both cases, the funding for non-profit entities is 100%, like in research and innovation actions. In the 2024 calls, we have only one topic in Destination 1 that uses this 60% funding. And the pilot that started in 2021 and will end in 2024 shows us so far that while obviously the contributions of industry increase with the 60% funding as opposed to the 70% funding, there is essentially no impact on the participation of industry. In other words, industry is just as interested in the topics with 60% funding. And as I said, there is now only one topic in the processes for Planet Partnership in 2024 that uses the 60% funding. Now, let me move to the business case and exploitation strategy. These are two features, both in Destination 1 and in Destination 2, with a few exceptions, like the coordination and support actions. So for most topics, research and innovation actions and innovation actions in Destinations 1 and 2, we ask proposers to come up with a so-called business case and an exploitation strategy. What does that mean? For the business case, what we have in mind is an understanding, an assessment, an initial assessment of the expected impact in terms of opportunities and also in terms of deployment capacities in the union, which of course come after in general, they come after the project. And by exploitation strategy, what we mean is not a complete exploitation plan. That would be too much to ask for in a research or innovation proposal, but basically an identification of what the needs are, what obstacles there may be, and how some of the obstacles could be overcome. And in particular for technology readiness level 7, which is about demonstrations in an industrial environment, and several of our innovation actions reach that technology readiness level, we ask for a credible strategy for the eventual full-scale deployment in the union. Now there is an option that proposers, consortia, can look at the skills that the needs for skills that arise from their technologies. And when they do that, they may opt to create some training material or provide training guidelines that could be upscaled elsewhere, for example, through the European Social Fund. So this is an option, but it is an important one, because very often we find that technologies, an obstacle in deploying technologies is the lack of skills. Next slide, please. And now we can move to the first part of Destination 1, which is the manufacturing industry.
Yes, thank you, Nicholas. We'll be moving to the first part that includes like 3 topics, a 2-stage topic and 2 presentations on the single stage. I would also like to remind the participants of the deadlines. The topics, the call is already open. It opened on the 19th of September and the deadline is the 7th of February for both single stage and 2-stage. We will be giving 3 presentations. The first one is for you, Nicholas. Then we have our colleague from DG Connect, Yves Pandavan, and the third topic is again for you, Nicholas. Can you see the slide? Yes. Is everything okay with you, Nicholas?
Yes.
Okay.
Thank you, Anna. So we will now present the first 3 topics in Destination 1, which are a part of the Made in Europe partnership, the co-program partnership that supports the discrete manufacturing industry. And essentially, it is about the circularity, the green and digital transition of the manufacturing industry. And the partnership as a whole focuses on 4 main objectives, which are excellence in manufacturing technologies, circularity, services, manufacturing services, and human-centric aspects that are often integrated in topics. And in 2020...
Sorry, Nicholas, to disturb you. Actually, my colleagues are telling me that in the web stream, the presentation doesn't work, so I will try to share it again.
Yes.
In this way, we can you see this? Okay. Okay. This is unseen. Can you try to share again the presentation in this way? Sorry about that. It's something that can happen in live streaming. And we will be there in 1 second. It's coming. Okay, let's go back to your first slide. Hopefully now is okay. I will be just checking with my colleagues if everything is okay now. No, they are telling me that it cannot be seen. You can continue. We will try to sort this because I have mixed messages. It seems that some people can see it, some cannot see it in WebEx.
All right. Thank you, Anna.
Sorry about that. Please continue.
Thank you, Anna. So I introduced the support for discrete manufacturing made in Europe as a whole. Let me remind you that, as Peter Dröll said earlier, this and all other partnership topics are open to all proposers. You do not have to be a member of a partnership. And so they function like any other topic in the work program. So let me start with the first of the three topics of 2024 for manufacturing, which is biointelligent manufacturing, and it is a research and innovation action. This is part of the two-stage goal for a reason that I will explain. Most of the topics for the Made in Europe partnership and other partnerships in Destination One are in the single stage goal, but this is an exception. It is in the two-stage goal that you saw on the earlier slide. Now, this topic is a fairly broad one. It is meant to, the intention is to explore the many opportunities that biointelligent manufacturing affords us with. So the topic is deliberately wide. We have discussed this extensively while we were drafting it. And as you will see in the scope, it leaves several possibilities open. One is to bio-inspired manufacturing processes. The other is biointelligent manufacturing systems, integrating biointelligent and bio-based materials in discrete manufacturing, and then more systemic approaches. And these are only examples. The scope says that the scope is not limited to this. However, it is very important to stress something that is definitely out of scope for this topic, and that is the pure development of materials or biomaterials. So even if it involves a manufacturing of materials in the sense of the production of materials, that would be out of scope in this topic. So here we are interested in the applications of biointelligent principles in the discrete manufacturing industry. So this is the one crucial limitation in this topic. This topic is not about materials as such. Now it is a topic for research and innovation actions. Relatively low technology readiness levels because of its exploratory nature. So it will start at TRL 4, aiming to achieve up to 6. That is a demonstration in an industrially relevant environment. And you can see here the expected outcomes. Basically, we want to explore the possibilities of biointelligent production and to begin to make these available to the mainstream manufacturing industry. with a goal of improving circularity and sustainability in general. And also because it is a very exciting and promising field. So this concludes the first topic. Now it is a two-stage. It is in the two-stage call precisely because it is rather broad. We don't know how many proposals we will receive, so we considered that it would be better to put it in a two-stage call so that we can first assess the initial ideas through a first stage proposal before asking some of the proposers to come up with a full proposal. This concludes the first topic, and now I will pass to my colleague Yves in DG Connect for the next topic in Made in Europe.
Good morning, everyone. I'm going now to talk about the Twin Transition 0103, and here what we have to see, this is manufacturing as a service. That is the use of the distributed production facilities that are made available as services. We know it's not new, but what we know is digital technologies are now making manufacturing as a service as an engine of growth if our industry is able to take that opportunity. My name is Yves Panaven, working in DG Connect A4, Digitalization of Industrial Ecosystems. This line of research and innovation here in 2024 builds on the projects called for in 2023 that were to model and make more resilient the value network thanks to manufacturing as a service. Here we have the objective to develop the technologies that make flexible, decentralized manufacturing, remanufacturing easily accessible to all industries and notably SMEs. Lowering the entry barriers, therefore, for industry to adopt this technology to produce on demand a large choice of customized products with high flexibility, short lead time. That is, products which are made to order in contrast to made to stock. The research topic aims to develop automation, emerging digital technologies for the servitization of manufacturing assets, leading to an offer from integrators, from machine tool developers, from software houses that will have to exhibit performance, faster configuration with a minimal downtime, remote monitoring, predictive maintenance. So all the nice quality that we are looking for in manufacturing as a service. It will have to make full use of data platform for fast, trusted, secure, interoperable data exchange among companies. So not only within, but also across the different companies. The type of development here includes digital design, development of design libraries, workflow templates, advanced technologies such as digital twins, a real-time AI-based decision support system, next generation manufacturing execution system, that is the production line operating system. This is what we are looking for. The improved value chain integration needs to be done through the availability of these technologies, of these models, to securely exchange and leverage the data of the manufacturing assets that will be servitized. Remember, we are talking of distributed production facilities all along their life cycle, and with a view to reuse, to recycle the assets, the components, the materials. We want that the projects here would optimize the entire life cycle of the product in terms of circularity, reusability, sustainability. So interoperability here will be a core requirement for manufacturing as a service. And for that reason, we also expect the projects to build on existing standards or contribute to standardization when it is relevant, and that they would take into account the state of the art that will exist at that moment in terms of digital product passport or manufacturing data spaces. So with 35 million, we expect projects in a range of 5 to 7 million each, and they have to bring the development to a level of demonstration of a prototype in an operational environment that will be tested in at least 2 realistic use cases in different supply chain or industry sectors. So really representing this major step in technology demonstrated readiness, so the TRL6 that we want to achieve at the end of the project. And from this, I give the floor back to you, Nicolas.
Thank you, Yves. And now we move to the third and last topic under Made in Europe for 2024. You may ask yourselves, incidentally, why we tend to have relatively few topics in this work program for Made in Europe. And the reason for that is that we are now trying to achieve a greater integration of technologies. So in 2023 and 2024, we have wider topics that seek to integrate technologies that have very often been developed in other successful Made in Europe and factories of the future projects in the past. That is why you see relatively few topics, but with relatively large budgets. So let me now move to the last topic for 2024. This topic is about the circular economy in manufacturing, and it builds on, of course, on the previous work on technologies for circular manufacturing. In particular, last year, many of you will remember a topic, 04, which was about the various technologies, both at factory level and at the level of value chains, to support circular manufacturing. This topic for 2024 takes circularity down one more step of integration, if you like, in that it looks at the whole ecosystem, including, very importantly, the data and the digital product passport. Because you cannot have circularity in manufacturing or anywhere else for that matter without a good data ecosystem. So that is one of the issues that is addressed here. So this topic is about the systemic approaches to make manufacturing and also manufactured products more circular. It has an overall budget of 36 million, and we expect projects of between 4 and 6 million. So the expectation is that at least 6 projects will be funded under the topic. It is a research and innovation action, like the 2 other topics for 2024, and it aims to achieve a technology readiness level of 6. That is a demonstrator in an industrially, one more demonstrators in an industrially relevant environment. And this brings us to the end of the 3 topics of 2024 for Made in Europe, for the discrete manufacturing industry. And now we are ready to take a number of questions from you. Thank you.
Thank you, Nicolas and Yves. I have been informed that there were some small issues at the beginning with the presentation, but we be able to share the presentation afterwards. So in principle, there shouldn't be any problem with that. May I ask my colleagues to put on the questions? I also would like to remind the audience to include the topic and speaker they are referring their question to. In this way, we can directly address the questions to the right speaker. So the first one, consider biointelligent manufacturing. What can be considered intelligent manufacturing? Nicolas, I think this one is for you. And the same is the second one. So we take the first 2, and then the third one is for Yves. Do you expect a tool that manages the entire manufacturing sector, or a solution that can then be applied to every type of industry? So about definition, and the second one is for you, Yves.
Yes, thank you, Anna. Indeed, let us take the first two questions together on biointelligent. So, in fact, as far as I know, there is no single definition of biointelligent manufacturing. One very relatively narrow aspect of biointelligent manufacturing is the use of biomaterials in manufacturing. But biointelligent manufacturing is much more than that. It is, as the topic says, one example is to make products that are in themselves biointelligent, that is, they use biological principles. Just to mention one random example that I happen to know about, you could have a DNA-based memory that instead of bits uses DNA. And let me come clean. I must say that I'm not a biologist, I'm a physicist. So this topic has arisen from many discussions with experts, both in manufacturing and also experts in this relatively new biointelligent manufacturing concept. Another example is to use various biologically, is to be inspired by nature in terms of the products that are made. That is not entirely new. Of course, there are lots of examples of technologies that imitate nature. So that could also be an example. And then finally, you could have various biologically inspired ways of making something, whether that is something, whether that something is biological in itself or not. So I hope this helps. As I said at the beginning, this is a deliberately wide topic. It is an exploratory topic. A lot of things would be within the scope, but let me say once again that just developing biomaterials would be out of scope. That is the one thing that is definitely out of scope. So I hope this helps with regard to the first two questions.
Thank you. Yves, would you like to take this, the second question?
Yes, certainly. So what we expect here in manufacturing as a service is actually a full range of tools, of very diverse tools that would tackle more specifically in each of the industry. You know, the manufacturing sector is very diverse and has very different processes, one with respect to the others. So we don't expect one tool. We expect really a full family of tools, a range of tools. What we ask in the call is that the tools would have interoperability. So that is, you are able as a producer to be in contact with your different suppliers, tier 1 suppliers, tier 2 suppliers, in a way that makes it really a full integrated, flexible value chain. So that's what we are looking for, really a number of tools, interoperable tools, secure, fast, etc.
Thank you. We have a last question. Coming up. Okay, the other question is, both of you can take it. It's, if it's made in Europe or it's made in space by European companies, can be considered made in Europe. Both of you, please, can give your opinion on this.
Yes, let me start. That is a very nice question. So first of all, Made in Europe is the name of the partnership. It is not an absolute rule. Of course, what we want to see is that projects will lead to production in Europe. And as I said at the beginning, we are asking in fact, the projects to show that this is a case for high technology readiness levels. That said, we are open to international cooperation in Made in Europe and in other topics. But certainly our vision is to see manufacturing being done in Europe on the basis of the technologies that we develop. So, of course, if European companies have production in space, when that happens, that will also be very good to see in the context of Made in Europe. Yves, would you like to add something to that?
Yes, I think that maybe some of the confusion might come from the fact that we were talking of manufacturing data spaces. Manufacturing data spaces is an infrastructure that we are currently aiming at deploying with the Digital Europe program, which aims at having data infrastructure where companies can exchange securely data, have connectors one with the other, and my data can be shared only with these companies and not with the others. So this is an infrastructure that is currently being deployed. So if you want, you can actually look it up for manufacturing data spaces or data spaces for the manufacturing industry to have a better understanding of what we mean here. And then if I take the question where do we expect the consortium to establish an infrastructure? No, we expect here the development to be more along the different equipments, digital design libraries, different technologies that could be further either developed, put on the market, or integrated with the machine tool providers or with legacy of different machine already on production lines. So that we really would like to have this additional layer of technology which enables manufacturing as a service to exist and to show its value for our companies.
Thank you, Nicholas. Would you like to take the one on demo cases? Are they required?
Yes, indeed. Are demo cases required in the circularity topic? Now, the topic aims for a technology readiness level of 6 at the end of the project. That does mean a demonstrator, but not necessarily one in an industrial environment. So it is, in effect, this topic is calling for in an industrially relevant demonstrators. That is what DRL6 means. Incidentally, most manufacturing projects do come up with a pilot or a demonstrator of one form or another. Of course, some are much more mature. In the case of innovation actions, you tend to get more mature demonstrators in successful projects. But yes, we do expect to see a demonstration in the broader sense of the word of the technologies that the project will develop.
I see more questions coming. Let me also remind the audience to put questions in Slido, not in the chat, because we consider only the ones that are in Slido. And the next one is for you, Yves. I would say this is probably the last question we can take, so then we can move on to the next presentation. Yves?
Yes, so the question is if we would address the case of an SME who wants to enter a new market with no investment in machinery. And indeed, the idea of manufacturing as a service is to be able for SMEs to even be a fabless company. That is, they would do the design, they would then entrust the production to a distributed manufacturing capacities, ensure the quality assurance later on, the follow-up and so on. So yes, that would typically be the case. We want to lower the entry barrier for SMEs to be able to produce in a manufacturing as a service context.
Okay, thank you very much. Let me thank you again, Nicholas and Yves, the speakers of this part of Destination 1. And we can move on to the next set of topics, the energy-intensive process industries, where we have 3 topics pertinent to Processes for Planet partnership. And I would like to invite the 2 speakers, Garbiñe Gullo Echeverria and Antonio Fernandez Garcia to take the floor. I would like also my colleague to move the slides to number 11, if possible. Can you move the slides, please? Thank you very much. We can go to the next one and start with Twin Transition 132 with our colleague from DG Research and Innovation, Garbiñe Guyo Echeverria. Are you with us?
I'm with you. Can you just confirm you can hear me well? Yes, for your smile, I see you
can hear you.
Thank you.
Thank you and welcome.
Thank you so much, Anna. So good morning to everybody. It's really a pleasure to be with all of you today. As Anna was saying, I'm Garbiñe Guyo Echeverria, and I'm working for DG RTD and in the unit dealing with industrial transformations. What we are going to do now is start with the topics that about energy intensive process industries. These are 5 topics that are divided in 2 sections. The first 3 topics is the ones that you see here, Twin Transition 32, 34 and 35, that are focused on the energy intensive process industries, climate neutrality and energy efficiency objectives. And after we take these 3 topics, we are going then to move to the Twin Transition 38 and 41, which are also part of these energy intensive industries topics. And there the objective is on circularity and resource efficiency. Why I'm talking about these 5 topics together is because all 5 of them are implementing the processes for Planet Co-Program Partnership. And in this sense, there were 2 main messages we want to pass to you, worth to remember. The first one is, even if the topics are implementing the partnership, these topics are open to everybody. You don't need to be a member of this partnership to participate. I think it's clear to everybody, but always worth remembering. And the second thing is that these 5 topics are about energy intensive industries. And you will see that the 5 topics we have the frequent asked questions, where we are explaining what these energy intensive industries are. Why I'm saying that? Because we want you to be aware that these topics are looking at the energy intensive industries, and if the proposal you are putting together are not targeting these industries, evaluators are instructed to reflect this in the evaluation on the impact criteria. These proposals will then be penalized. So should you have any doubt after reading these frequent asked questions, go to the national contact point and they will contact us if needed, if you need us to clarify anything on this respect. And then without further ado, I move then to the first topic, which is the Twin Transition 32, optimization of thermal energy flows in the process industries. And if I may just ask the next slide, please. Okay, I can start anyhow. So in this topic is a topic that has an indicative budget of 30 million euros, and we are expecting to be able to finance between then 2 or 3 proposals. It's an innovation action, and we are talking about TRLs that start at TRL 5 and achieving TRL 7 at the end of the project. So we're talking about system prototype demonstrators in the operational environment at the end of the project. If I have the next slide, that will help the audience, I suppose, to follow the topic, but I'm sure you are trying to move it. So what this topic is about. The idea here is that more than 60% of the overall energy that is used on the process industries, and here we are talking steel, cement, chemical industry, ceramics, etc., is heating. And then with this in mind, what we are looking is to highly process integrated technologies that will allow heat recovery and use of high temperature installations. what is important to keep in mind here is that what we are talking about is about integration. In Cluster 5, our ENER colleagues have had several topics and then several projects that were looking at heat pumps, at heat exchangers. So they were looking already at these technologies. But what we need is to be able to integrate these technologies into the process industries. And this is what this topic is about. You will see that in the topic descriptions, we are giving examples. Please keep in mind, and this is true for all the topics, these are just illustrative examples. They are by no means an exhaustive list, okay? So you say, do we need to work on this? Well, no, these are just examples. What is very important for you to keep in mind is that here we are talking about the integration of heat exchangers and the heat pumps in high temperature processes. I already have questions. Can a proposal be on heat storage? Well, I mean, you can consider heat storage if you are talking about something intermediary, but the topics are the topic is not about heat storage. We are talking in the topic also about a height safety standard technologies, very important, and of course about fluids, use of fluids that are low environmental impact. We are saying there also that you may consider advanced materials, no obligation, but you may consider it. What is interesting in this topic is that we are talking about high TRL levels, TRL 7 at the end of the project. And if you think about the way the EU works and the different financing possibilities, you may think, okay, after Horizon Europe, I may go to innovation funds. So basically what we were trying also to put in the topic test is that at the end of the project, you will have the tools that will allow you to move to innovation fund or to move also to other kind of financing that will go to higher TRL levels, TRL 8, etc. Thank you. I see that the next slide is there. So that's why you will see that in the text we are talking about the inclusion of greenhouse gas emission avoidance methodologies, and if possible that you follow the methodology that Innovation Fund has developed. We were told that SMEs may have issues following this methodology, so it's not an obligation, but a recommendation. And then also we were talking about at the end of the project, not the beginning, but at the end of the project, that you have plans for scalability, commercialization, deployment, etc. Again, this is linked to the fact that we are thinking, okay, which are the criteria of innovation funds? Then which are the expected outcomes? Well, you have them there. I don't need to go too much in detail there. But of course, we want to demonstrate highly process integrated solutions. Again, the integrated is the kind of the key word. Demonstrate substantial increase on the flexibility of the process, contribute to achieving EU climate neutrality goals, and of course also report EU objectives, and then at the end of the day enable the increase of the competitiveness and resilience of the European process industries. And with this I finalized this topic and I pass the floor to my colleague Antonio Ferrandez, who will go through the next two topics.
Thank you, Garbiñe, for the floor. Anna, should I start? Do you hear me well?
Yes, please. I just want to say that we have a slight delay with the slides. You might have noticed as well, but please go ahead and we'll try to sort that.
Okay, no, I see that the slide is correct. Hi, my name is Antonio Ferrandez. I'm policy officer from the Unity 3 in the Directorate General of Research and Innovation and colleague of Garbiñe, and we are presenting the topics of processes for planet. I'm presenting these next two topics. This is the 34. Is a renewable hydrogen used as feedstock in innovative production routes. It has, as you can see in the slide, a budget of 20 million. So we expect two projects from 8 to 10 million each. This is a research and innovation action, meaning that it will start at technology in readiness level 4, that it is validation in laboratory, and it will aim to 6, that meaning that this technology can be demonstrated in relevant industrial environment. I think that we all know that hydrogen, when used in industrial processes, obviously doesn't emit CO2. So this will help in decreasing the average greenhouse gases emissions of industrial processes. And this is the reason integrating hydrogen is so important for meeting our 2050 climate neutrality goals. In energy intensive process industries, hydrogen can be used either as energy carrier or as feedstock, I mean, as a chemical or as a reducing agent. So in the last work program, there was a topic of hydrogen as energy carrier in energy intensive industries. In this work program 24, this topic is about using hydrogen as feedstock. No need to say that the use of hydrogen as feedstock to produce fuels, it's out of the scope of this topic. So, well, that's the background. Hydrogen actually is already used in many industrial sectors as feedstock. But besides those common or regular uses, there are different production routes under development that we want to promote. For instance, using hydrogen as a reducing agent in the production and recovery of metals, or in biogenic and circular carbon optimization, and also to produce platform chemicals. So what do we expect from these proposals? The proposal should first develop innovative production routes using hydrogen as feedstock, like the topic title. Second, evaluate the integration of these new production routes into the processing line. Third, design this production process by using simulation, modeling, and IT tools. And four, include the energy efficiency and economic studies and life cycle assessments of the whole process, including the hydrogen. I mean, the hydrogen LCA, the production, storage, distribution, and use of the hydrogen. Like in all cases that we've mentioned, my colleagues' proposals should include a business case and an exploitation strategy, and study the social and environmental impact and the implication for the workforce. The proposal should collaborate with other existing projects, cooperate with the Clean Hydrogen Joint Undertaking if it's relevant, and finally participate to the activities of the Trust Database and the Hydrogen Observatory. With this, I finish this topic. If the chair, Anna, allows me, I can continue with the second one and to the next slide, please.
Please go ahead.
Okay, I don't know if, well, we have a delay no, in the slides.
Yes, so unfortunately we do.
No problem.
We'll take a few seconds, maybe if you can
I will start speaking about the background. Okay. So here, the 35, that is about turning CO2 emissions from the process industries to feedstock. Like in hydrogen, we want the CO2 to be feedstock of a process. Again, this topic has a higher amount of budget. There's an indicative of 30 million euros. So we expect 2 to 3 projects of 10 to 10 million euros each. This is an innovation action, meaning that it will go further in the technology readiness level, starting at 5, that is validation in relevant industrial environment, and aiming to achieve 7, that is a prototype demonstration in operational environment. This is a capture and utilization topic. You can see for the technology readiness level, we want more. So the proposals are expected to demonstrate the economic viability of the CCUS from point sources and cover the streams into added value chemicals and materials. So we want deployment. So this semi-industrial demonstrator should process significant amounts of CO and CO2 from energy-intensive process industry, demonstrate the cost-efficient technologies of capture, purification, and the conversion of the CO and CO2 into chemicals and materials, evaluate the energy efficiency of the overall process, and also consider the flexibility due to the use of renewable energy, use advanced monitoring and control, means the integration of digitalization, and integrate fully the process, integrate fully into the process and promote maximum energy efficiency. What we don't want is that mean the fit is the purpose and we spend more energy in the CCUS than in avoiding the emission. And last, include the techno-economic study and the societal and environmental impact. Now, the proposals. They need to be viable and feasible and needs to be demonstrated with economic return. They need to include the greenhouse gas emission methodology, as Garbiñe mentioned, to facilitate synergies with the Innovation Fund. Proposal needs preliminary plans for scalability, commercialization, and deployment, and to indicate the possible funding sources to be potentially used for rolling up this technology. For example, the innovation funds, thus including this greenhouse gas emission methodology. And the proposal should collaborate with other existing projects, and the outcomes might benefit the establishment of the hubs for circularity. Finally, we encourage synergies with projects from the topic Horizon Cluster 5 2024 D30211, that is a CCU for the production of fuels. And I think that's all. Thank you very much for your attention. And if there are any questions, Garbiñe and myself, we are happy to reply.
Thank you, colleagues. Let's see if we can get any questions. Okay, we have the first one for Garbiñe. In terms of greenhouse gas avoidance methodology scenario, should include any relevant emission in the boxes. The processes is quite detailed. Would you have any comments on that, Garbiñe?
Sorry, I was muted. What we were saying there is that we were recommending to include the greenhouse gas avoidance methodology, and if possible, that this follows innovation funds methodology, but we are not imposing any kind of methodology or exactly what needs to be done there. So it's very open. It's for us the first step to start moving on that direction. So not obligations of X scenarios or what should include there. Yeah.
Antonio, the second one I think is for you on the hydrogen used as feedstock. The products.
Okay, see feedstock ammonia or methanol. If it's a more efficient route and it's an innovative route, okay. If you then are going to use the ammonia or methanol to produce fuels, it's out of the scope.
Okay, that was pretty clear. I think it was quite clear and direct. Thank you. I'm not sure we have other questions. I think we don't, so it was pretty clear. Thank you again for your presentation. We are in line with the time, so I will move now to the next part, which is on circularity and zero pollution in process industries. And for that, we have our colleague Marcella McAndrew from the GRTD, and Garbiñe, you are also there. If my colleagues can move to slide 16, to the pertinent slides, I will ask Marcella.
Hello, good morning.
Take the floor. Good morning.
Good morning, Anna. Indeed, thank you very much. So we are moving on with the next topic concerning the circularity. So I think I will not make any further introduction because Garbiñe has already introduced the overall requirements or overall conditions for the 5 topics. So if I can ask for the next slide, and we can go for the topic on the hubs for circularity for the industrialized urban peripheral areas. So yes, I think that we have the correct slide now on the screen. I will probably not read all the expected outcomes or all the slides, just to recap for the indicative budget. So for this topic, we are planning 40 million euros, and again expecting 2 to 3 projects, around 15 to 20 million per project. Why is this topic on the table, or what do we expect? This topic is really about connecting the urban areas where there we have high volumes of waste and the adjacent industries. So engaging the local synergies for finding innovative solutions for regional resource management. We are looking in this respect for semi-industrial scale demonstration, So integration of the flow of the urban waste in the process industries, and where applicable, downstream manufacturing, construction, and other industries. What should the proposals themselves address? So from this perspective, we are looking at the systemic solutions for the hubs for circularity. This should contain a technological but also non-technological part. And there is a strong focus on the regional and interregional aspects. From this perspective, the proposals can address the materials, water or energy use, or a combination of those. Part of what we are also looking at is really accompanying the solutions with digital tools that can promote the recycling, sensor-based waste sorting, modeling tools, material passports, and so on. And the proposal should also address some establishment of IT infrastructure. This not necessarily has to be within the same location as the demonstrators, and can serve multiple hubs. The proposals are not looking only at the modeling of the symbiosis within the area or within the region, but also look for co-development of strategies with urban district heating networks. So this should be also something that can be considered. And we are also looking at the use of established methodologies. The proposals should include not only a business case, but also exploitation strategy. So look a little bit forward. It needs to have a replication and adaptation side of the concept, including the simulation and the business case. And then we are obviously looking for 2 or 3 alternative locations as is stated in the program. And an important part is also really this joint interactions between the industry and the local community. So we are also looking at the educational aspects and inclusion to extend the hubs for additional players or participants. I will stop probably this introduction here and see if there are any questions for clarification, and I will pass the floor next to Garbine for the other part.
Okay, so I suppose I take the next topic before we move to the questions. So this brings us to the last topic of processes for planet, and the second topic for this part on circularity and resource efficiency. And this topic is the Twin Transition F41, breakthroughs to improve process industry resource efficiency. Here we have an indicative budget of 30 million euros, and we should be able to finance between 2 and 3 proposals. This is a relatively low arterial level compared to the others, and here we are talking about a research and innovation action that starts at arterial 4, ends up at arterial 6, technology demonstrated in relevant environment. I will say this is a very, very ambitious topic when you see the kind of breakthroughs we are talking about, and we are aiming to end up to arterial 6, but let's see. So what this is about here, what we are looking is for radically new approaches. We are really looking for breakthroughs that will lead to much higher resource efficiency, including selectivity, less low value byproducts and waste them by definition if we have better efficiency, and also enabling to handle higher feedstocks variability. What is important here, I should maybe have mentioned it before, in this topic, when we are talking about resources, we are talking about raw materials efficiency. So resources here is raw materials. Resources are also energy, is also water, but what happens is that in the goals of 2023, we already have 2 topics, one working looking at efficiency on water and another efficiency of energy. So here we decided we will really focus on the efficiency and making the best of the raw materials. You will see that in this topic are plenty of examples. I think within our discussions with the stakeholders, there was this need of giving examples of which are real breakthroughs and what can be considered there. Again, what is important for you to understand is that these are just examples, illustrative examples, by no means in an exhaustive list. What we are saying there also is that you may make use of advanced materials or artificial intelligence. Again, not obligation, but it's something that could be considered. When you look at expected impacts, what we are saying there is that we are aiming at achieving a step change in the process industry green transformation by improving at least 30% of the industrial process resource efficiency compared to the state of the art. 30% is enormous. We are aware that this is really very ambitious. When we are talking here about the industrial processes, we don't mean that you need, if you are talking about a steel industry, that you need to have a 30% increase or improvement in the whole process industry, but maybe you can focus on one or the other step within this process industry and look at maximizing this part. I think that is what quite a lot of proposals may be looking at. Then another expected outcome will be enabling the techno-economic then feasibility of these novel technologies, an overall positive environmental impact, reduction of the CO2 intensity, and then enable to increase the competitiveness and resilience of the European process industry for sure. And this brings us to the end of this second topic, and together with Marcela, it will be our pleasure to try and answer the questions you may have.
Thank you, Marcela and Garbinia. Indeed, we have completed our session on circularity and zero pollution in process industries. I see quite a few questions. Maybe we can start with you, Garbinia. Can we include demos at end users our processes outside of process industries?
Yeah, so demos can be included. Now we are really talking there about breakthroughs, so we are not expecting big demos. I think what is really important is that you are showing that that these are real breakthroughs. And then when I look in the food producer using PET created by our new technique. Yeah, well, I will just food is not food and feed is not part of energy intensive industries, but what I read there, I suppose that you are looking at the part which is the plastic, the PET, so that will be part of the chemical industry and will be within the scope. Again, this is breakthroughs, this is low temperature, low TRL levels, and we are looking for radically new approaches. So I think this is the main issue here.
Okay, thank you. I will go to the last one, and then maybe we can call in Antonio, because I see that the first one is more for Antonio. Marcella, if I understand correctly, if a project with an industrial estate in a big city where there is a mixed industrial food manufacturer is in scope.
Well, indeed, I'm also trying to look at the question. It is a bit of a statement, but it is indeed targeting specifically the relationship between urban waste and their reuse in the process industries. It is important to say that we would be really looking at the upcycling of waste, but indeed, if I understand correctly, a big city with mixed industrial waste and its reintegration in the process industries is something that is strongly targeted by this call compared to what is now the current call for the year 2023. So really this utilization of the big city, but also then scalability and the replication to similar model, and really looking at the strategic way how to close the loop of the waste stream or resource management within the wider urban industrial area.
Okay, the second one, I think they are moving. So yes, the first one now is also for you. In terms of achieving the Fit for 55 package objective, greenhouse gas reduction of systemic solutions should achieve 55 as foreseen in by 2030 strategy. This for you, Marcella, as well. It's a bit.
It's a little bit
okay.
wider question. I do not necessarily think that the project itself should reach a 55% reduction, but I think it should contribute and should be in line with the target of decreasing the CO2 emissions, the greenhouse gas emissions, because normally the rationale between is that by closing the loops we are decreasing indeed the emissions, and therefore there is a direct link between the resource management and circularity and decrease in the greenhouse gas emissions. I do not know whether Garbiñe has any other reflection on this part, but this is the understanding. So
yeah, I will
specifically
agree with
for
that.
the project, yes.
Yeah. Maybe Anna, I can answer the next one. I'm not very sure.
Yeah,
but
sure.
The cost of the pilot is part of the cost of the project. I'm sure that Hadea colleagues will be a better place to answer to that. But yes, we were asking for pilots there, so this is part of the cost of the project. And can this investment be used later for the commercial process? Yes. Then in this this topic we were talking about TRL7, so this is kind of okay. We will need to see exactly, but this is not such a high TRL or such a high size pilot either. So I wonder how you are going to have a pilot that is TRL7 and then you are going to use for commercial. So it's something kind of not so straightforward for me there. But the pilot, the cost of the pilot is part of the topic. Yeah.
Okay, thank you. I think we do not have other questions for the moment, so we can move. Thank you, Marcella and Garbiñe, and we can move to the next part of the destination, which is on a clean steel and the two topics pertinent to the Clean Steel Partnership. I see Alessandra Colli, colleague from DGRTD, is with us, and she will go through the two topics, Twin Transition 144 and 146. If also my colleague could move to slide 20, then we can start with Alessandra.
Thank you, Anna, and good morning to everyone. So we now look into the clean steel topics that are the topic 44 and 46 for the year 2024. You can go directly to the first slide, to the topic 44, and we target directly each single topic. So overall, for both topics, we have a 30 million amount of budget for this year. Specifically for the topic 44, we are targeting a 10 million budget in total, with averagely 3 to 5 million per project. This is a lump sum approach for this topic. This is an innovation action targeting specifically digital transformation. So digital approaches going through, so the scope is reaching out to sensors, to statistical analysis, to statistical data, application of analytical capabilities, so going also in the direction of artificial intelligence, knowledge-based approaches, database models, and including also the skills. One of the aspects that we are really taking very much into consideration is also developing skills for targeting the need of skills also in the industry. So please take into consideration that also when developing digital models, especially and digital approaches, the involvement of operators and experts is really strongly suggested because of the involvement directly of the industry and the creation of skills and capabilities inside the industry when the new digital approaches are then finally applied. This is a topic that targets various aspects of the digitalization. So we go also from sensor, also in terms of possible development of new sensors, applications of new sensors, and similar things. Concerning statistics, there is these are extremely relevant. There is a very much need of statistical data, possibly open data approaches. So maybe also to take into that into consideration, and transforming that, transferring also this data in application into modeling. The outcomes that are expected, of course, they are targeting enhancement of inline processes, extension of inline and real-time tools, also novel sensors, as was said before, traceability of material, application of digital technologies and methods, and all areas. So in principle, there is a very wide opening to all the area of digitalization. This again is an innovation action with the nice part that 70% is funded. I think this for these topics should be more or less it should be more or less clear. We can pass now to the second topic that is slightly longer and wider. So next slide.
So, there is a little delay. Sorry, Alessandra,
I realize. Anyhow, I can start speaking about the topic 46 in the meantime. So the topic 46 is a portfolio topic, and it's covering two technological areas. One is the CO2 neutral steel production with hydrogen, secondary carbon carrier and electricity. Or second technology area, innovative steel application for low CO2 emission. Remember that this topic covers these two technology areas, and you have to apply for one or the other, not both of them. Not both areas are required to be addressed in this topic. So let's look a moment into the first technology area, that is the enhanced CO2 neutral steel production with hydrogen, secondary carbon carrier, and electricity. So here these are the outcomes that are expected. These are listed here on the slide. However, let's look a moment in what is the scope, because the scope is really targeting reduction processes. So not reduction processes, but also heating or reheating processes. Anyhow, processes where we can, let's say, apply a new type of CO2 neutral carbon sources, for example, where we can modify the process, addressing modification. The scope is also going towards existing a new installation, trying to address this type of modifications in the system. Is also looking into internal and external flow and preparation of gases. And this is in terms of preparation of gases for use, but also as a recycled gases like CO or CO2. This is targeting specifically, so this can target actually different technology. We can go to direct reduction of hydrogen or using hydrogen, to electric arc furnaces, to electrolysis. So really understanding the low CO2 production of steel and the technologies associated. What are the outcomes that we expect under this part is the introduction, of course, of secondary carbon sources in the steel making process. better if of bio origin, then combine the reduction of fossil carbon related emission with improvement of material and energy flow, adapt the use of low CO2 hydrogen for heating in rolling, shaping, and heat treatment. So this is going also the application of hydrogen as a fuel in the process. The revalorization of non-conventional ore, for example, in processes like the photoelectrolysis processes, substitution of fossil sources as carburizers, and identify and analyze the amount of European existing technology that could be efficiently retrofitted to CO2 neutral solution, like, for example, hydrogen DRI. This is also an important aspect that the Commission is very eager to know, and not only my DG, but also as the other DGs like DG Clima. We can pass now to the next slide that is covering the second technology area of this topic 46. And this second technology area is focused on innovative steel application for low CO2 emissions. In this area, which is the second one, the scope is really to target new type of alloys, new type of product in terms of outcome of the manufacturing processes, and especially to understand what are the weaknesses and strengths of these products, to analyze, for example, the capability to withstand certain type of environment, introduce also material analytic capabilities. One of the aspects that is coming out this year also in these topics is the use and the collaboration with analytical facility, material analytical facilities, like they could be synchrotron or a neutron facility, but not only, of course, there are various other analytical approaches based on microscopy that can be also introduced to have a better overview and a better collection of data and information about the material. The purpose here is really to connect what is happening at process level with the material that we obtain as an outcome, in a way that we can validate also the material itself for use in the industry. So in principle, this objective is preparing the ground for the marketability of new alloys and steel products developed with innovative approaches that are also looking into low CO2 emissions. Of course, as you know, changing a process, it means also changing the outcome. Some process variables can affect enormously the outcome in the product, and this is where we want to target. So we are looking as an outcome into new and modified alloy concept, manufacturing of steel for a specific type of application, improve, for example, clean steel grades with improved in-use properties. This can go in the direction, for example, of applications in railways, in cars. So this is a very, very open topics in terms of targeting the applications. So there you see also, for example, railway and high-speed trains are mentioned also at advanced grade of steel that could target that area. Steel grade with increased use of low quality, for example, input materials, also try to valorize a little bit more the scrap and so on. This is both of these technology area that I mentioned under topic 46, they are more at research level. Let's say here we are talking about a TRL from 4 to 5, maybe possibly 6. And this is a research and innovation action type of objective. So here the budget is 20 million. Let's remember also that being a portfolio topic, the approach is to fund at least, of course, if they are a reasonable project and evaluated accordingly, to fund at least one project under each of the technology area. Here we're talking about a project in the range of 3 to 5 million, with an overall, of course, amount of budget available of 20 million. I think this is more or less it for the description, and if there are questions, happy to answer.
Thank you, Alessandra, for this very clear presentation of the two topics. We now see if there are any questions. Will projects that address production of aluminium also be covered? If not, is there another program for funding research on ferrous metals?
No, aluminium is not covered. So the production of aluminium is not covered under this area here. We are talking specifically about the clean steel topics. So the target of the topics is specifically production of steel. The topics are implementing the Clean Steel Partnership. So I would suggest also to refer to the Strategic Research and Innovation Agenda. That is the SRIA of the partnership that is available under the STEP website. There in the SRIA is very clear what are the areas that are targeted, and their aluminium, of course, the production of aluminium is not covered. However, in respect to the non-ferrous metal, as far as this has been a question coming out also in other contexts, non-ferrous metals can be, part of the development if associated with steel and part of the steel alloy. So as far as it's very well known, steel is not only including iron, but steel alloy can include also other chemical elements that are considered non-ferrous metals. And if there is a collaboration with the steel industry that is bringing on the table also possibility of having specific alloys, including non-ferrous metals, that is welcome. But specifically only the production of aluminium, no, is not covered. I go a moment to the second question for topic 44. Technologies for melting of pre-reduced and reduced ore, scrap and iron rich low value reducers should contribute to 6 areas of interventions. I don't know, it's not clear to me if this is under topic 44, because it seems to me more that this is, as far as we're talking about technologies for melting of pre-reduced and reduced ore, scrap. So this sounds more pertinent to me to the topic 46 first area. However, it's not necessary to contribute to all the 6 areas of intervention of the SRIA document. If the project contributes to at least one, it's already a good approach. It's not anyhow necessary that they contribute to all the 6 of them. Is there an extension of 3 pages in the proposal for exploitation and business cases? That I think is more a question probably for Adea.
Yes, I think all these questions will be addressed this afternoon. Will be also a specific session on the application process and the evaluation criteria. So this is the questions more related to the that process will be for this afternoon. So if we don't have any more specific questions on the topics that Alessandra was presenting, we can thank you very much, Alessandra Colli, for joining us. And we move to the last part of the destination 1. And we have the 2-stage call now. If my colleagues can go to the pertinent slide, thank you very much. This is one topic on a new way to build accelerating disruptive change in construction, and we have Philippe Mosley from DG Grow to tell us a bit more about this topic.
Hello.
Thank you very much.
Thank you. Very nice to be with you today, and we have this single topic on construction this year, focusing on civil engineering infrastructure. And before I describe the topic, I can point out that there's an important FAQ in the topic description defining what we mean by civil engineering infrastructure, because we did have a few questions on that early on. So it excludes buildings, first of all, and it includes most other types of infrastructure works. But it also excludes certain energy-related infrastructure like electricity pylons, because that would have a different kind of well, yeah, a different type of actors would do that, and also, you know, there are energy related calls elsewhere. But all other types of engineering infrastructure, such as tunnels, bridges, roads, pipelines, dams, waterways, all kinds of things like that are included in this topic. This topic overall is looking at the need to, first of all, extend the service life. Maybe we can go to the slide that's got the expected outcomes in the description. Yes, thank you. So the overall aim of this topic, and the first bullet there, is extending the service life of infrastructure, which means you know, when infrastructure is built, it can often live with good maintenance for decades or even centuries. And if we don't maintain it and we let it decay, then it needs to be replaced or demolished, and that has negative environmental impacts and also negative costs. And in Europe, we have thousands and thousands of decaying and old infrastructure which needs maintenance, and often these are dangerous or difficult to access, and also it can be quite difficult to find out what the needs are. So that's what this research topic is really looking at. It's about anticipating problems before they occur and then dealing with those problems. To give you an example, a recent example that probably everybody knows is the Morandi Bridge in Geneva that collapsed with no notice, the motorway bridge, and that was found to be, from problems with the metal in the bridge. But there are also many other examples of urgent repairs that need to be done at a higher cost perhaps than would otherwise be the case. We also have in this topic so first of all, we need to detect these problems in infrastructures. Then we need to have a rapid detection and analysis of what the maintenance repair needs might be, and then a kind of the health and safety aspect is also important. So workers may need to ascend for great heights or go to dangerous places in large structures, especially where maybe that might not always be necessary. And then there are also the cost savings, as I mentioned, the avoided cost of building new infrastructure, but also the savings that we could expect from better detection and better analysis of what the needs are. Could also save operational costs. So I think that when it comes to what the proposal should do, the topic describes a number of bullet points, but especially the top 4 bullet points as you look at the topic description in the scope, describes what the technologies that would need to be developed. So they are about identifying, they're about monitoring and analyzing, they're about making recommendations, so intelligently recommending and prioritizing the action that would need to be taken. And then also, so as well as that just identification and analysis, there's also a requirement to develop solutions that would actually carry out the rapid, cost-effective and safe intervention. So that's the key part of the topic. And then also there are a number of other things that are, addressing the risks associated with health and safety, and then looking at ways that the data coming from all of this analysis and work could interact with with other maybe construction related data. And then the topic should also contribute to standardization, because standards are very important here. And then also we have some possibilities to collaborate with other calls or with other projects in other parts of Horizon Europe. There are For example, the new European Bauhaus is one area that maybe could be explored by proposals, or possibly areas like in Cluster 5, the Built for People partnership, could also be an area, or there are missions and so on. So there are maybe some synergies that could be explored with other parts. And finally, we would look for the topic to integrate insights in social sciences and humanities, specifically regarding how workers would carry out tasks and respond to safety issues. As you can see on the slide, that you can see the budget and the contribution per topic and the TRL to achieve 6 in this RIA topic. Thank you very much, and I'd be happy to answer any questions.
Thank you, Philip. Let's see if there are any questions. Okay. Is the topic looking a new technology, at the new technology for applying plate with fibrous cementitious material in scope? So it's more about fibrous cementitious materials, if that is in scope.
That sounds like it's a material related question. I mean, you'd have to look carefully at that, but I mean, there are also, you know, possibly other areas at Horizon that would look more at the material development side of things, including the EIC potentially, because I know that they've been looking at cement in the European Innovation Council, so you could look at that as well.
Next, wind turbines or wind farms, are they excluded?
That I'd have to check carefully the FAQ as it's written, because it's quite specific. From memory, I think they're not excluded, but we would need to check that on the FAQ that are on the topic description, and I haven't got it in front of me, but yeah.
Okay. Let's go to the next one. Successful proposal, are they required to cover different aspects of civil engineering infrastructure, or can they have a specific focus?
Yes, there's no problem having a specific focus. Bridges only could even be, you know, bridges made out of a particular type of material, like steel bridges or concrete bridges or even wood bridges, because you know the scale of what we're talking about, there are thousands and thousands of bridges in Europe, all over the place, of different materials. So even if you were to focus down to something like that, you would still have a fairly wide application. So I don't think there's a danger of being too specific if you focus on one type of infrastructure.
Next one, are pilot foreseen expected in the proposal? Do you expect pilot?
Well, I mean, that depends on, you know, how you deal with the TRL level. It's only up to 6, so it's not it's a research action rather than an innovation action. And typically, you know, for those for research actions, it's not necessarily you know, essential to have a pilot.
Okay, thank you very much, Philip. I'm just checking with my colleagues if there are any more questions on this topic. Here it comes another one. Are you looking for digital twin for monitoring modeling and in situ monitoring using sensing like acoustic emission and numerical modeling of cracking issues?
Those things all sound like they could potentially be relevant. So, you know, that without going into detail, I think that, you know, there are many other examples potentially as well of technologies that could be relevant here.
Thank you. They are popping up. Sorry, I read also with you.
It's okay. It's good that we have questions.
Indeed. Is a project looking, oh, well, this is financial survey and rapid post-tensioning system for extending the life of concrete structure in scope. I think this is very technical. Would you
Yeah, I
able
think that's
to
the sort of
comment on
question
this?
you should probably look at for your national contact point to have very specific questions like this about individual proposals. I think that the text of the topic is clear enough. There are many different aspects of maintenance and repair, not only structural. They could be related to corrosion, they could be related to moisture, they could be related to all kinds of other things which are, listed as examples in the topic description, but there may be others as well.
Thank you, Philip. I think there are no more questions, and I would thank Philip mostly, but also all the speakers of this session. We are slightly ahead of time, so we can, I believe we can close the destination 1 part, and I invite you to connect again at 2 for the next part, that's destination 2, and this afternoon there will be also presentation on more the application steps and the evaluation criteria, and also some presentation on the national contact point that was mentioned also earlier by Philip. Thank you very much for joining us, and see you later.